So there's that. There's this. And then there's this. So welcome, welcome, welcome. Hopefully you can hear me. And we're going to be talking about the abacus. What is this thing? This thing is the abacus. This is an abacus. This abacus is going to help us count. When we learn how to count, we're going to count 1, 2, 3, 4. Because this is 4, then we have 5. How do we know this is 5? All the top bead has a value of 5. So what we're doing is we're learning how to count and use the abacus. This abacus is a counting tool. It is a math manipulative, and it's a forgotten tool. It's a forgotten tool. It is a forgotten tool because nobody knows how to use it, but it's been around for like centuries, like hundreds and hundreds and thousands of years. Thousands? Probably thousands. Yeah, I think so. So this is 5, and then we count. This is 6. This is 7. This is 8. This is 9. Let me know if you have any questions, and if I'm going too fast. If I'm going too fast, let me know, and I can always repeat myself because we can always do a little review. So what we're doing is we're understanding how to read the abacus. So again, we're going to do 1, 2, 3, 4. Because this is 4, the top bead will be 5. The top bead is always going to be 5. Yes! Hello, everybody. Hello. So we're counting 1, 2, 3, 4. And the top bead is 5. Because this is 5, then we have 6, 7, 8, and then 9. After 9 is 10. That's how we see it. So when we look, we have 0. This is 0. And then this is 1. And then we have 2. So this is 2. And then we have 3. Oh, I should move this. This is 3. Sometimes it's just easier to see the numbers. So when we see 3, right? And then this is 4. There's 4. Now what's after 4 is 5. 5 will always be the top bead. Let me see if I can find the number 5. Oh, here it is. Here's the number 5, right? 5. 5 will always be the top bead. So this is 5, and then we have 6, we have 7, we have 8, we have 9. Okay, so anybody have any questions? Hello, hello, welcome, welcome, welcome. So what we're doing is we're reading the abacus, and because we're reading the abacus, we are understanding how to use it. After we learn how to read it, we're going to actually start learning how to add and subtract and multiply and divide. But it all depends on how fast we can go for multiplying and dividing. Okay, so the first thing we're going to do is we're going to count 1, 2, 3, 4. And then we have 5. After 5, thank you so much for liking the live. 5, and then 6, 7, 8, and then 9. After 9, we have 10. How do I know that's 10? Well, just as how we write, let me see if I can find my little, here it is. Just as how we write, right, the 10 looks like a 1 and a 0. 1 and a 0. And so when we look, that's not going to, there. So when we look, we have the 10s, and then every column is a place value. We have our 1s, our 10s, our thousands, our 10,000. Wait, our 1s, our 10s, our hundreds, our thousands, and our 10,000. So then you might be asking, why am I starting over here? It's because I have this thing called I have this dot indicator. This dot indicator lets me know that this is my 1s place. So if you notice, my 1s is right here, and it tells me that this is the 1s. So when we count, we have 5. 5 will look like that. This is also 5, but this 5 is actually 50. Why? Because we're in the 10s place. And then if I move this is 500. How do I know? Because we're at the hundreds place. And then this is 5,000. And then after 5,000 is 10,000. So, 50,000. So when we go back, we have 1, 2, 3, 3, and then 4. After 4, we have 5. There's 6, 7, 8, 9, and then 10. Thank you so much for liking the lives. Anybody have any questions? Because I feel like I'm just counting. So what we're doing is we're understanding how to read the abacus. So when we look at it, we're just counting. So this is 10. When this is 10, right after 10, we have 11. Right after 11. What's after 11? Well, this is what 11 looks like. Huh? What? 1 and 1. 1, 1, and then 12. Ooh, that's 12. How do I know this is 12? Because this is my 10s and this is my 1s. Hello, it's a pigeon. This is a cool thing. Oh, thank you so much. Thank you so much. I appreciate it, but I didn't invent it. All right, but I got jokes. Hey, It's the pigeon. Let me know if you have any questions because it seems like you're the only one here. And now I can talk to you. Thank you for the follow because you're only commenting. So I'm like, okay, I have somebody to talk to. Now this is fun. It's more fun when I have somebody to talk to. But let me know if you have any questions. I'm the one chatting. Yeah, you're the only one chatting. So, yep. All right. So we're gonna count. We're gonna count. We have one. So this is what we call the horizontal bar. This horizontal bar is what counts the beads. Did the Chinese invent the abacus? I was doing some research and it sounded like the Chinese did invent this. There is a specific style of an abacus. This is the Chinese style of the abacus. And so there was actually other variations of an abacus. So there's the 10 bead one, and then there's like all these that. So the one that the Chinese did, it comes like this. This is specifically Chinese. And the Chinese one invented this one, but then the Japanese came around and said, you know what, we're going to make it more efficient. But then I was doing more research. Yeah. So it's the tool. It's ancient, right? Well, you know how there's those videos and you see those kids doing this? They're actually doing the abacus. She's teaching right now. Nurse? What? I wish I knew how to do this. I wish I learned. Oh, yeah. Yeah. So what we're going to do is you know what? Let's move this aside and let's start counting again. So when we count, we're going to count on the abacus. We have 1, 2, 3, 4. What level abacus are you? I think I'm a 10. I mean, I've been teaching abacus for 20 years, so I know I know abacus. I don't have it in my head. So this is 4 and then on the top bead will always be 5 because this is the top bead. So all of these touching the horizontal bar is all considered 5. If you notice, it all depends on the positioning of the beads. So because the positions of the beads is touching this horizontal bar, these are all counted as 5. This is all 4. Does that make sense? So I like the Japanese one. I like the Japanese. Oh, you know what? I like the Japanese one, but then I started looking at it and I was doing some research. You can actually do kind of like times table. So 6 times 1 is 6. 6 times 2 is 12. And then we have to trade this in. So this is 12. And then 6 times 3 is 18. Wow, this is cool. Anyways, so yeah, I learned the abacus for 4 years and I quit just last year. Oh, you didn't like the abacus? So that means you know all the way up to multiplication and division. Can the abacus used for a calculus math equation? No, no. Abacus is only used for arithmetic, adding, subtracting, multiplication, and division. That's all it's being used for. So we're going to count. This is 1, 2, 3, 4, and then 5. We have 6, 7, 8, 9, and then we have 10. How do I know that this is 10? 10? Okay. I didn't think so, but I wanted to ask. Yeah, no, that's a really good question because there's some people that ask, like, can you do differential? And I'm like, I don't know because that's above my pay grade. I'm a simpleton. I only know how to add and subtract. You might be able to get calculus out of it, but I don't know how to do calculus. So I'm not the best person to ask. Oh, but what's his name? Apollo. Maybe Apollo knows calculus. Apollo, do you think you can do calculus with the abacus? I actually don't know. I don't know. Multiplication is pretty simple. Yeah, yeah. Oh, you only know multiplication when the simple one. Oh, that's interesting. Like I can go like 5 beads and I can go 5 beads across. So I think I can get like 10 beads, but it's just the same thing over and over again. So we're going to count again. So notice we have our ones, our tens, our hundreds, our thousands, our 10,000 because this is intriguing. Grabs popcorn. That's funny. So we have ones, tens, hundred thousands, 10,000. When we look, we have 2, 22, 222, 2,222, and then 22,222. Does that make sense? So I'm also very good at visualizing. Oh, you know what? I'm not so good at visualization. Visualizing. I learned abacus. Oh, how old were you when you learned abacus, Apollo? I learned abacus when I was old, so it's harder for me to see it, and I don't practice a lot. I just teach it. And then my kids, I have 3 boys, and they all do the abacus, but I don't push them to memorize it either. We don't do too much. We don't do too much with the abacus because, after a while, then they do like other things in school and stuff. And so they don't really focus on the abacus anymore. They did their whole curriculum, and then after they finished the curriculum, then it was just like, okay, you do what you need to do. I started around 8. Okay, yeah, eight's a good age. 8 is a good age. So 4 years, yeah, that's about right. Because it takes about 4.5 years to finish the curriculum. And then kids always get busy. So we're counting one, two, three, four. This is four. Hello, user 06856013056. Yeah. So what we're doing is we're counting the abacus. This abacus is showing me that this is four beads being counted. How do I know it's being counted? Because it's touching this horizontal bar. This is the reckoning bar. This is the crossbar. So when the beads are touching this horizontal bar, this is what's being counted. So when we do this, if you notice, none of the beads are touching the horizontal bar. So that means that these columns are not being counted. These are all zeros. However, if I did this, then we would have to use this as a zero. So this would be 40. Why? Because I have my tens and I have my ones. So if I have a zero here, then I can start talking about my a zero as a placeholder. So I have a four and a zero, and then this is five. The top B will always be five, no matter what. So this is actually 50. How do I know that this is five and this is 50? Well, this is my dot indicator. This dot indicator is my ones place. This is my ones indicator. Does that make sense? Thank you guys so much for liking the live. So when we look, we have our ones, but wait a minute. There's another one right here. Well, yes. You could use that one as your ones indicator. So what we could do, hey, Jesse James, welcome back. So we have the ones and the tens, but notice that if I use this dot over here, this indicator, then I don't have any more hundreds. So what's going to happen is I usually use this one over here, so then I have bigger numbers. So it really just matters, like the bigger the abacus, the more numbers you can use. Because why? Because size matters. Abacus live, yeah, yo. So this is a 13 column abacus. And if you notice, it has more dots. So there's a dot here, 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 here. So when I look at this, I have my ones, tens, hundred, thousands, 10,000. But then when I look over here, I have my ones, my thousands, my millions, my billions, and my trillions. I did not do trillions, but this is what it would look like. There we go. There we go. And then if you notice, the decimal sits between, oh, that didn't look good. The decimal sits between the ones and the tenths. So what I did was I have my billions. Right. So my ones, my tens, my hundreds, my thousands. And notice that the dot is every grouping. I have that one. Oh yeah, you have this one? Yeah. This one's a good one. So we have our ones, ones, our thousands, our millions, and our billions. So when we are looking at it, you can use these labels to know where you are. So it's easy to see that this is my thousands. When I have it, right? When I have it, I could move to this one in the middle. Then I would have to shift all of my columns to this way. So it'd be my ones, tens, hundred thousands, 10,000, 100,000, millions. Okay. So that is a little bit about learning how to read the abacus. So, but if we wanted to track our national debt, we would have to get a bigger abacus, which is 23 columns. Because the national debt has a lot of digits. So what we're going to do is it's the same thing and they work exactly the same. So what's the difference between the three? They're all the same. The only thing that's really different is just the size. And again, size matters. So this is 23 columns, this is 13 columns, and this one is only 7 columns. So usually I use this one for the younger kids and then I graduate them to a bigger abacus, which is the 13 column one. The colors don't mean anything. It just matters about the location of the top B. Yeah, you like that? Yeah, I got jokes. I got jokes. If you stick around, I got more jokes. Okay, so if you notice, it's always the location of the beads. We have the top beads, right? And we have the bottom beads. We have the bottom beads, and these are the bottom beads. When the top beads touch the horizontal bar, when it touches the cross bar, when it touches the reckoning bar, then we're being counted. So if I line this up, this is 5. The top bead is touching the horizontal bar, so this is 5. So when we look, this is 6, right? So it works exactly the same. It works exactly the same. The only difference in the matters doesn't matter. The only reason why I like to use a colorful one because it's easier on the eyes. Wow, I was wondering what you would do for the bigger numbers. That makes sense. Yeah, right. Because of the national debt. I was doing some research. I don't actually put my products. I don't put my divisor, multipliers, and all this and that on my abacus, I use the paper. But people have used the abacus for tracking their numbers as well. The top one's the 5 beat and the 1 1. Yes, yes. Thank you, Sam. Yes, exactly. Do you find it easier teaching children the abacus? I do find it easier to teach the children abacus. The reason why is because we can we can immediately show how to subtract. Do you ever test your viewers on questions? I do. I do. I have a book. So this book we start talking about what do you call it? We start looking at the questions. So what this is a maze, and this maze is one of the things that I do. And we can do it right now if we're all ready. If we're all ready, we can do it right now. But I need to find my yeah. Let's see. Where did it go? I need to find no. Oh, here it is. Right. Yes. Yes, right? So what we're going to do is the first thing we're going to do. Oh, you're ready, Jesse? So the first thing we're going to do is we're going to learn to read the abacus. Are you going to do a problem? I always wanted to learn how to use it. Yes. It depends on how quickly we can do it. I used a sheet with 30 questions. Oh, yeah. See, Apollo. But mine is better. You know why? Because mine's are activities. I know what yours look like, and it's really boring. And so I actually made it into activities where the kids can have fun. So I have it where there's a maze, and all you have to do is like find the answer, and then it is very abacus specific. So you answer this question and you follow the path. You answer this question and you follow the path. So that's one. This one is a color by number, and after color by number, I have word problems, and then I have what is it? Find the hidden word. Yeah. Thank you for the share. Again, there's more color by number, and I have puzzles. Where's my puzzles? I have more puzzles. Yeah. I know. Where can I get that? Oh yeah, you wanna it's over here. Oh nope, that's the wrong one. Yeah. So that's me. Hi, my name is Lynette. My name is Lynette Young. You can find it here. And so, Apollo, I know how boring your questions are. And I made it more exciting. We got you all over the place. Yeah, right. But I'm just so excited because you know why? Because Apollo's questions were super boring, and so the problem. And when I was thinking about it, I was like, okay, this is the most I've always hated. Yeah, right. So here, Apollo, look, I have puzzles, and inside my puzzles, you answer the question, and then you find the answer on this puzzle, and you slap it together. I know how I know your questions, and I wanted to be different. And so that was like, this is about learning the plus tens. This one is learning the plus fives. And then I made the preschool one. Oh, hold on just a minute. And I made the preschool one. And the preschool one is making sure that the kids know how to read the numbers from 0 to 9. And then there's whoa, and then hey Bella. And so this one is another activity. Do you ever have high school level? I'm top level 1. Do you ever have high school? No, actually I don't have a high schools because by then they're finished and they have a lot of homework, and then they don't have time to do abacus because abacus is really done for arithmetic. So after a while they don't need to. Okay, so we are going to look at my maze. Because Jesse James is ready. Oh, right. So what we're going to do is also while everybody answers the question, I'm going to give you a little review. I don't know what your name is. I just see a little symbol. So this is how an abacus works. The abacus works like this. We have 1, 2, 3, 4. So when we're looking at here, we're trying to figure out what number this is. So everybody in the chat, if you know what this number is, let me know. So this is 4 because it's touching the horizontal bar. Because it's touching the horizontal bar, and then we have 5. The top B will always be 5. So we have 5, 6, 7, 8, 9. So when I look at this is so refreshing to see a teacher so enthusiastic about the things they're teaching. Oh, yay! Yeah, see, Apollo! But you're wrong. Thank you. It's a pigeon. Sam got it. You know why? Because it's 5, 6, 7. So what does it look like? 700, 0, and then 6. Thank you so much for sharing the live. So yes, this is. So I'm going to color in 706. Typo. Yes, I know. I know. I know. Okay, so I have that symbol, but I don't know what the symbol is. I don't know what your symbol is. So what we're going to do is what's our next number? And again, all the top bead, how do you hey shat? How do you add and subtract? We will do adding subtracting after we figure out how to read the abacus. When everybody understands how to read the abacus, then we can go into adding and subtracting. So we have 5, 6, 7, 8, 9. And then if you notice, this is 9. After 9, we have 10. This is what 10 looks like. And now this, if you notice, this is a 3-digit number. Because it's a 3-digit number, and Sam has said it correctly, I have my 5. That's 5. That's what that looks like. And then I have 9. 9. 5, 6, 7, 8, 9. And then 0. Exactly. So my answer is 590. 590. And then we're going to continue again. When we look, we have this is so fun. Oh, thank you so much, Sam. I do appreciate it. I try very hard to be creative with abacus, and I feel sorry for Apollo not knowing me earlier, but I do believe my activities are fun. And that's what this book is. That's what I have. But this one right now is only 2-digit. I'm going to have 3-digit. I will have 4-digit and 5-digit with decimals. But right now we're just doing 3-digit. Yes, thank you. So we have 3, right? 1, 2, 3, 312. 1 and the 2. So we have 312. And then what we're going to do is we're going to find 312. And then we go to the next maze, next piece of the puzzle. So we have, it's a pigeon. Are you still there? You okay? Are we okay? That number and then this number. Sam's really getting into it. I'm so happy you like it. Hey, E, welcome back. So this is 51. And then we have this. What is after that? We have this, this, and that. So the first thing, okay, good. Does the numbers make sense to you? 192. 192. 100, 5, 6, 7, 8, 9, and then 2. Yes, perfect. Thank you, user 0685. Right. So then we have this one. This one's easy. And the only reason why I did that is because I colored it for you guys, but then after a while it doesn't get colored. So this is fun. Thank you so much. Yeah, see, this is easy. Easy. You know why? Because these are always going to be the 55. Ooh, Jay, you need the 0. So when we look, this is my dot indicator. This dot indicator is my ones place. So I have my ones, my hundreds, my ones, my tens, my hundreds. So this would be 550. 5 and a 0. Yep. There we go. And then we do that. And then we have that. All right. What's next? So we have 3-digit. We are doing a 3-digit number. So when I did this activity, I wanted to make sure that was 3 digits. So we were practicing how to do 3 digits. And then that's what it is. Yep. Cool. Thank you. Yes, Apollo. We have 300. Hey, Hannah, yes. Good job. 300. 1, 2, 3, 8, 5, 6, 7, 8, and then 1. And then we have 381. Yes, thank you, Jesse and Jeffser. 14. 381. Oh, we got to go over here. And then this one is easy too. How do I know? How do I know? Because I made it. So we have this one. And then after that is, what is our number? Yes, thank you, Sam. Whew, that's fast, right? Easy, easy, simple to use, easy to understand. And so once we get this solid, then we can go into how to move the beads. And after we know how to move the beads, then we can go into adding and subtracting. This is cool. How is it slowly making more sense? Right? Not Ricky. You're right. Not Ricky. How about questions? We will be doing questions after everybody understands how to read the abacus. There's a whole plan. Be patient, Apollo. Okay, so what number is this? This is that. We have that. And we have that. So after we after we understand how to read the abacus, thank you. Hey, welcome back, Packers. After we do learning how to read the abacus, then we start learning how to move the abacus. The blue is 5. That is correct. That is correct. So we have 5, 6, 7, 8, 9, and then we have 1 and then 3. 1, 2, 3. Yes, thank you, user and Packers. So 1, 2, 3. There we are. And now we're here. So in the book, oh yeah, we can talk about it in a little bit. So we have this number, and then, oh, notice I didn't color it in anymore. So idea is, as you go through it, you'd be coloring it in, and it'd be 5, and then 1, 2, 3. So it'd be 3, and then 5, 6, 7, 8. Yes, 538. Yes, you're absolutely right. I just got here. Oh, well, good job, Packer. I just started. Okay, 538. So I'm still full of energy until I crash, and then I will have to end the live. So we have this number, and then that. Yes, how did we go? How did we do? So we have this number, and then we have this number, and that's it. Woohoo! Thank you. Thank you, thank you, thank you. Ah, thank you, Sam, for the finger heart. Woo! Okay, it's the pigeon says 870. We need to have the zero user. If you look, 5678, right? This is 800. 567, this is 70, and then we have a zero. Almost. I don't know. Are you a teddy bear? I think your name's a teddy bear. Hey, Balia. What we're going to do is we're going to read the abacus. And oh, we're at the last one. So when we look, we have 1, 2, 3, 4. This is 4. Every time the beads are touching this beam, that means this is being counted. So this is 4. When we look, this will always be 5 no matter what. This is 5. If I did all of this and all of this is touching, that's all 5. So if I clear it, this is all 0. So the blue bead is always 5. Exactly. Exactly. So if I did this and I did this would be 6. Why? 5, 6. So if you notice, I count from 5 and I can add 1. So when I do this, it's 5, 6, 7. So we have this number, 5, 6, 7. So this is 7, right? And then we have the top bead, which is over here. And then we have 4, 1, 2, 3, 4. 4 bottom beads. Does that make sense? Can you multiply and divide, only add and subtract? No, you can do multiplication and division on the abacus. Yes. We will do that depending on how the energy is. Okay, so what is this number? Oh, yes, thank you. Balia and Jeffser. Yeah, it's if it's touching. Exactly. And they all have to touch this horizontal bar. They all have to touch this reckoning bar. I don't know how many. I call it the beam. In the abacus world, we call it the beam. But in oh yeah, 4, 7, 5, 4. So, just so you know, this is available. I just got this published too. I'm really quite excited. And so this one's available on the other platform, which is over here, and that's my name. And it's kind of cool. So there is, I think, 14 puzzles. I have 14 puzzles, and the answers are in the back. And then there's a reverse maze. And what's a reverse maze? I'll show you what the reverse maze is. And I'm actually working on my 9th book. Again, if you notice, there's the beginning part, and then the beginning part gives you the information like how to read the abacus, and then it talks about just the beads and what it looks like. So this is just a little precursor, and then after that, this is the mask maze that I have. But if you don't like how thin it is, you can get this mask maze from my website, and you can download it. It's a free download. You just gotta scan this QR code, and then you can get this, and then you can actually print it out on cardstock. And so that's what I use. That's why you can't see through it. I do like it. I do like this idea. So then, because it's kind of easy to see. So then the next one was called. I called it a reverse maze, and the reason why I called it a reverse maze was because I show you the path of the maze, and I need to. Oh, here it is. So this is the other set where I show you the path of the maze. Because I show you the path of the maze, then you have to go back and you have to tell me what number this is. So this is 3. So what I would have to do is I have to color it in 1, 2, 3, and then it comes down to here, and notice your path is this. So you have to show me what 36 is. So 36 is 1, 2, 3, and then 5, 6, and then over here, right, this is empty, so my path is going this way, and this is why I call it the reverse, because you got to go forward in order to go backwards. So it takes me down to here, and we need to know what this number is, 23. So it's 2 beads on the tens, and 3 beads on the ones. Does that make sense? So this is what I call the reverse maze, because you kind of know what it is, but then you need to write the answer. So that was one, and then this one is 70, right? So this is 5, 6, 7. And then we keep going. This is 30, and then this is 5. And then over here, this is 78. So this is 5, 6, 7, 5, 6, 7, 8. And then we have this one over here, which is 9. 5, 6, 7, 8, 9, and then 9. So 90. We have this one goes this way, 5, 6, 7, 5, 6, 7. So 77 goes up to here, and then my answer is 6, and my final answer here is 72. So it's 5, 6, 7, and then 2. There we go. I've been crunching the numbers on my abacus. That's fantastic. That's fantastic. So that's what my reverse maze is. And so I think there's 14 of them as well. And if you want extra, I do provide extra. You just got to go to my website to go get it. Um, so and I give you instructions. So these are the instructions, what a reverse maze is, and then what it is you look at the number and then you put in the path. You color the counted beads from the previous. And then if you wanted more, I have extra free mazes if you like that. But that's what I got. And then this one also comes with answers. Yeah. Yeah. Cool. What are the white numbers for? Oh, it's to help the person who's reading the book to go through the book. So the way I have it is, if you look, the numbers, because it's white, you were to color it in. That's why. Will teaching the abacus help understand place value? Yes, it does, because it's all about place value. So if I have my place value, I know that this is my ones, my tens. Oh, sorry. This is my ones, my tens, my hundreds, my thousands, and my 10,000. Does that make sense? So, Kayla, the white numbers. You mean this one right here, right? This is for you to color it in, to keep track of it. So you notice that I was coloring it in. So that the idea was for you to color it in if you bought the book. Yeah. It's the pigeon. How? Oh, okay. So going back to place value. So when we look, this is the place value. And then if you choose this one to be your ones, then you have your ones, your tens, your hundred, your thousands, your 10,000. However, if you chose this one to be your ones, then you would move everything over and this would be your ones and your tens. But notice, no, the white versus the blue color background. Oh, yeah. So this, or you're talking about this. This is the answers. This is the answers. No, the white and the blue colored one. Okay, so this is my reverse maze, and I give you the number, and then you're supposed to color in the counted beads. So because this is 3, I'm going to color in 3 beads. 1, 2, 3. Does that make sense? And so then what's going to happen is I follow the box and I go here, and my next number is 36. So I have to go through here and I'll do 3. 1, 2, 3. This is 30, and then I have 6. So this is 36. The white ones are just filler numbered. It's extremely late for me, so I must go. Oh yeah, sorry. Thank you. It's a pigeon. I hope to see you in my next live. Chat. The longest one that I've seen is probably the 23 column one. Have a good night. It was great talking with you. Thank you so much for joining me. So, chat. This is the longest one that I have. I'm sure there's longer ones. I don't know. Are those the numbers I'm talking about? The fillers? Why are they fillers? Why are they fillers? That's the one. Oh, you know why? So then you can practice and get some interaction going, because I didn't want it to be boring. So I just thought it was kind of nice to be able to color it in, like kind of like coloring book, but not really. So then the idea was, I know I need to go here, but I don't know what the number is, so I have to come here to see what my number is, and this is 20. So I go back here and I fill in the number 20. So this would be 2, and then this would be 0. And then after that, I come down here because I've already filled this in. I come down here, and then my next question is, how do I show what 23 is? So 23 is 2, right? 20, and then 3. 1, 2, 3. Does that make sense, Kayla? So when I do go over here, my question is well, what's the number? I believe she's asking about the unhighlighted paths. The unhighlighted paths, these ones, this one, the reason why it's colored is because I colored it. And it was just easier to show, but it's actually supposed to be not colored. And it's up to you guys to color it in if you wanted to. So the way I have it was, so the way I have it was, I mean, it's easy to see. So then some people like to, some people, I don't know, want to make sure that they count it so that you can color it in. And then this one, why do you do this? Just curious. I enjoyed the abacus and I'm trying to tell the world how beautiful abacus is. And it's usually for the kids. So my original thought was to try to teach the children and try to get it out there. And a lot of people don't know what an abacus is, or a lot of people don't even know what the word abacus does. And so you create the path, let the blue zigzag pattern. Yes, so there's two of them, right? One path is you got to figure out what the number is, and then you have to find what number, and then you have to find your own path. The second one is, this one is the path is given to you, but the abacus is not given to you. What are the numbers that you're not using for? Oh, those are just to make sure that they're not um easy to know, right? Thanks for clarifying. I understand now. Yeah, yeah. Do the yeah. The reason why I have it, so then I don't know, it was just the template that I have. I can't wrap my head around how you add subtract to vacation. Do you think kids rely on calculators too much now using tangible tools like the abacus? Well, it depends on how old the kids are. If the kids are 5 and they're using calculators, that's a huge no-no, right? If the kids are 11, they're not supposed to be using a calculator. If the kids are 16, 17, then they should be using a calculator, right? So it all depends on how old these kids are. I mean, it's a valid question, but we also have to think about the perspective of the calculator, right? The perspective of the user of the calculator. You know what I mean? So I mean, we have a lot of tangibles. I mean, if you really want to know, we have these math manipulatives that they're using, right? What's another math manipulative that they use? Oh, guess what? They do some drawing as well. Um, I'm not being, I'm just being salty because we get all these things, right? Like, how do you make 300, 348? We teach the kids, oh, you need to make 3 boxes, and this is what you call new math, right? So this is 346. 1, 2, 3, 4, 5, 6. So we're teaching kids this, and these are kids. Are they relying on calculators? This is not a calculator. This is what they're teaching because they want to try to get them to understand what the quantity is. So, Shat, your question specifically is not really valid. So, unless you can tell me how old the kids are that are using a calculator, but I will tell you this: that if they're 5 and they're using a calculator, I for sure know that they don't know what their numbers are. You know what I mean? So that's kind of a more loaded question. Okay, so that's what this is. That's what this is. Kayla, did I answer your question? I'm not sure if I answered your question. Like, I'm not sure if I answered. When are we doing a problem with the abacus? We'll do the Okay, good. We'll do when we learn how to move the beats. We got to learn how to move the beats. So the next one we're going to do is understand how to move the beats. Good. Kayla, let me know if you have any more questions. I do appreciate it because I want to make sure it makes sense. And if it doesn't make sense, then there's no point of continuing on. You know what I mean? Okay. So the first thing we're going to do is understand. Now, the reason why we go it this way is because in school we are always talking about how do you make an 8, but making an 8 is a result, whereas making how to make an 8 is not what we're trying to do. What we're trying to do is understand, and what we focus on in Abacus World is we want to focus on the add-in. So with the add-in, we want to make sure we understand how to use the number 1. When we have 5, I'm going to bring down the 5 and then I want to add the 1. As I add the 1, I just want you to move the 1 bead. That's all I'm doing. So what I'm doing is I'm adding the 1 bead, and it doesn't matter which bead as long as it's 1 bead. And now what we're doing is we're moving the beads. When we go through and understanding how the beads move, then we can go into understanding how to add and subtract. Does that make sense? So if you notice, this abacus is very delicate. You can lose your answers very quickly. So I recommend that you hold your abacus and hopefully you're on a flat surface, because if it's on a flat surface, then can I get the abacus at the Dollar Tree? I no, you can't. Unless you, yeah, no, you can't. You can get it on Teachers Pay Teachers. You can buy the specific worksheets, or you can go to my website and you can buy worksheets, or you can buy but nothing that I have done is in the Dollar Tree right now. I'm not that big. You know what, Kayla? I'm not that big yet. But when I do get big, I will have it at the Dollar Tree. But for right now, no, I apologize. I'm just starting right now to go into the whole internet. So I do hope I become that big that I can get my stuff into the Dollar Tree. But that is a place that I would like to start going into. So again, what we're going to do is when we did the plus one, now we're going to do a plus two. When we look at a two, right? Again, what we're doing is we're looking at our add-in. When we have the 5, we want to add the 2. When we add the 2, I'm only moving these 2 beads. I love monetizing. I love monetizing basic numeracy. Yes. So when we add the 5, we have 7. We have 5, 6, 7. And then if you notice, we're looking at the thumb up, right? The finger thumb up, the 2 beads. So if I have 6, this is my 6. What I'm doing is I'm adding 2 beads. I'm adding 6 and I want to add these 2 beads. When I add these 2 beads, I'm just moving these 2 up. So what I'm doing is I'm just showing to see how to move these beads. Does that make sense? So what we're doing is we're understanding how the beads move. Now notice if I add the beads, I can subtract the beads. So what does that mean? I'm going to add to the horizontal bar. I go to the horizontal bar and I add 2. When I subtract from the horizontal bar, I move it away from the horizontal bar. So which is interesting because a lot of the kids don't understand this. I just want to be like those kids that you, yeah, yeah, it's about practice. I mean, you could do it. Yeah, I mean, it takes practice. I mean, actually, I don't know. Apollo left, but I'm sure Apollo does it too. He started Abacus, she, Apollo started Abacus when Apollo was 8. So I'm sure Apollo would be able to do it. But yeah, so this is 6, and then we add the 2. We want to add the 2 beads. When we are doing it, notice that I'm moving these 2 beads. And then when I have it, right, after that is the plus 3. After the 3, we have 5, and then we add the 3. When we add the 3, 1, 2, 3, I want to move these 3 beads, just like that. How do they memorize it in their head? I feel like I'd forget. It's about practice. It's like playing the piano. How do you remember how to play the piano? It's just like that. Or how do you remember how to ride a bike? It's just like that. It's just all about, hello, Neon Panther, welcome. It's been a while. Okay, so that's about adding the 3, and then we're going to add the 4. Adding the 4 is not too bad. All it is just adding all these 4 beads. So there's not too many questions with adding the 4. It's either 5 plus 4 or 0 plus 4. So the answer is 4. And then again, remember, if we can add, we can subtract. So when we subtract, what we're doing is we're taking away. If I have 8 and I want to take away 1, I'm going to have my final answer is 7. So notice we're not focusing on the result, we are focusing on the added. And again, each question goes through, I'm making sure that we understand how to move the beads. When we add the 5, and again, we take away the 5. So we add the 5, take away the 5. When we add the 5, take away the 5. Notice that when I move the beads, I don't know if you can see it, but when I move the beads, I'm only touching the ridge of the bead. Whoa, the ridge of the bead. So no matter how big your hands get, you should be able to move these. This is a standard size of an abacus, just so you know. So even if I have my 23 column abacus, if you look, the sizes is very similar, right? It's just the difference is the amount of digits. That's all it is. This one actually has smaller beads. I don't know if you can see it. This one actually has smaller beads compared to this one. Yeah, right? So I know some people have complained about that. They want it to be bigger. It's like no, it doesn't get bigger. This is the standard size. So this is 5, and then after 5 we have 6, and then 6 is what? 5 on top, 1 on bottom, and we bring it together. 6. That's 6. And when we take away the 6, we want to push it apart. When we have 7, we want to push it together, and then we take it away 7. When we have 8, we have 5, 6, 7, 8, and then we take it apart like that. So does it matter what one you move at the top? Are they all 5? Is it just the 5th one? It doesn't matter which one you move. Kathleen. However, it does matter your place value. So if I decide to do this and this is all five, this is five 50, right? Now we're at 55,555.55, if that makes sense. The little black dot is the ones, to the left is the tens, and the right is the tenths. That is very much correct. And it doesn't matter which of the black dot you're going to use. You can use this one or this one. It doesn't matter. This one also has the same thing, right? It doesn't matter which dot you use. This one, that one, it doesn't matter. So you just have to move the place value. So if I choose this one as my ones, just like a Pokemon, I choose you, then this would be my ones. If I chose this one, then I move everything over and that would be my ones place. Does that make sense? Okay, good. Okay, good, Kathleen. Good. What the what? Sophie. I appreciate that. Yeah, not a problem. Not a problem. And so it's sometimes it's a little difficult to see, but that's why we take time to go back and to review. When we review, and I do switch out between the two, and I notice sometimes I use the dots a little bit too much, and people can't keep up. So I try to stay with this one um, for the ones place. And then if you notice, this one has a lot more. So if I made it this way, right? This is my ones, and then I have my place value. So I have my ones, my tens, my hundreds, my thousands, 10,000, 100,000, millions. So notice also the dots will help you group the numbers, right? My ones, my thousands, my millions, my billions. Kathleen, does that make sense? Yeah. So then again, if you notice, this is the decimal, right? Anytime we're after the decimal, right, is going to be the tenths, the hundredths, and the thousandths. Yeah. But I do appreciate the question when we look at it, right? So, and again, this is very movable. It just depends on how big or how small your number is. Yeah. All right. So we did a little bit about how to read the abacus. We did a little bit how to move the abacus, and let's do a little bit because Sophie is a little bit lost. Thank you, Sophie, for letting me know. I love the way you explain everything. Thank you again. Not a problem. The maze. Well, yeah, I would like to do the maze, but I don't think Sophie actually even knows what the beads mean. So the beads here, right? These are the beads. So anytime that the beads are touching this horizontal bar, Sophie, are you still around? Because if you're not, I'm going to leave. Okay, go. I think Sophie's still here. Sophie, are you still here? So this is one. This is two. This is three. This is four. I think she left. After four, I think she was too confused. After four, this is five. After five, we have six, seven, eight, and nine. After nine, we have 10. Oh, I think she left. Okay. All right. So we've done the maze. We've moved the beads. Now we're going to get into adding and subtracting. When we do some adding and subtracting, if you notice, we're going to do some simple adding and subtracting. Why? Because I want to make sure we understand. Yeah, that's all right. It's all right. People come and go. People come and go. If they don't have the patience to stick around a little bit, then that's fine. So we're going to do this. I don't, yeah. Okay. So here, because Chat's been waiting. Oh, that's right. Chat's been waiting, and then Chat's been very patient. Okay. Thank you, Chat, for waiting. So now what we're going to do is we're doing some adding and subtracting. We know how to add, right? We know how to add. We did 3 plus 6, right? Not a problem. Now what's going to happen is, what if I had from what if I what? So what if I have 55? So I have 55 and I subtract 5. Remove, yes, exactly. So my final answer is 50. Exactly. Exactly. But that's not the question you were looking for. You know what the question you're looking for is, what happens when there's not enough beads? That's the big question. Why? Because notice when I was moving the beads, I always had enough, right? I always had enough. I want to add 2, I'm going to add another 2. My answer is 4. If I want to add 3 and I want to add the 5, is there enough? Yes, I can. Not right now, Neon. Not right now. Let's do the minus the 5 and plus the 5. Because why? Because we need to understand how to make a 5. Why are we going to learn how to make a 5? Well, in school, we're teaching the children how to make a 5. This is a concept that we're teaching the kids, how to make a 5. Now, in abacus world, we actually level up this concept. Okay, Hang in there. Hang in there. Right? So why are we going to do that? Well, the question would be, let's say 3 plus 4. Shut. Just so you know, we don't memorize doubles. What we memorize is a formula. So there's this thing, right? We have this idea, we have that concept. What we're going to do is we're going to have this concept, but why are we going to use it? The reason why we're going to use it is because we need to figure out another way to add. When we add the 3 and I want to add the 4, notice I don't have enough beads to add the 4. Because I don't have enough beads to add the 4, I have a way to add a 4. I'm going to utilize the 5. So what I'm going to do is I'm going to make my freeloading 5 work for me, if that makes sense. So this freeloading 5 is actually going to be utilized. What we're going to do is we're going to isolate this variable. Why? Because this 4 and this 4 is the same. What's going to happen is I'm going to make it equal to 5. Notice that the 5 is now unbalanced. I need to balance it. I'm going to be 1 minus the 1. Now what we're going to do is we're going to substitute this information into this 4. How and why? Well, it's actually directions. So what the abacus did is actually gave me directions. I'm going to add the 5. That's what it says here. I'm going to add the 5 and I'm going to take away the 1. Because when I add the 5 it was too much. I only want 4 and my final answer is 7. Chat, did that make sense? Hey, Purple Pandas and Prince, welcome back. It's been a little bit. Right. Does that make sense, chat? Let's do it again. Let's do another one. So here's another one. The other one is 4. And when we do 4, ah, oh, good. Thank you. I do appreciate that because sometimes people are like, why are you making it more complicated? We don't make it complicated. We're actually teaching the children how to do this. So when we teach the children how to do this, we don't tell them to memorize, right? We don't tell them to memorize 4 plus 4 because 4 plus 4 only goes one way and it's not very versatile. Adding the 4 plus the 5 minus the 1 is versatile. So let me show you this next question. I have 4. The question is I'm going to add another 4. There's not enough beads to add the 4. What do? I have my directions. I say I'm going to add the 5 and I'm going to take away the 1. So my final answer is 8. So notice that we had to know how to read our abacus, right? In order to move it. We actually are doing the calculations in our head. We're only moving the beads on the abacus. The abacus is dumb. There's nothing in the abacus, but what the abacus does is it helps us track our numbers, right, Sam? Thank you. I do find it very fascinating. And so when we do this one, let's do another one, right? When we do another one, I want to add the 2. Notice all I'm doing is adding 2 beads. And the thing is because the abacus provides a constraint, we now know how to manipulate and get what we need. So we want to add the 4. When we add the 4, all we have to do is utilize this 5, which is the same concept here, right? But now we're using it. We're using it to our advantage, which is add the 5 and take away the 1. And my final answer is 6. Great. I'm so happy you guys like it. You know why? Because I get a lot of kickback and I get a lot of people saying, this is too complicated. You're making it way harder than it is. It's like, it's not, because you have to think about the young kids, right? Kids don't know how to add. They just know how to memorize. And if they know how to memorize, then it's not helping them. But this is critical thinking. How about when we move the numbers to the... Sam's got it. Guess what? What about the bigger numbers? You know what? Okay. Okay. So what's going to happen is there's 2 sets of numbers that we need to do. So you understand that there's one set. One set is this. We have the 4 and 1, 1 and 4. That's one pair, right? We have another pair, which is 3 and 2, 2 and 3. That's another pair, right? That's fine. So it seems like that you guys, hello, MC. Hold on just a minute. Let me finish my thought. So Sam and Kathleen, you guys were on the right track. Now what we do is, and you know about it, we talk about how to make a 10. When we make a 10, hold on, Nora. When we make a 10, we do the same thing. The concept is still very similar. Let me finish my thought and we'll go back to review. Hold on just a minute, EMC and Nora. So here is the other book. This book is talking about how to utilize the 10. Again, what we're doing is we are trying to make sure that our numbers are not freeloading, right? We don't want any freeloading numbers. So let me finish this concept and then we'll go back and review. So when remember we have this, right? We've seen this before. We're going to do is what we're going to isolate it. Why? Because my number is 9. When I add, let me do this one first. So I will have the 4 and I want to add the 9. Notice I don't have enough beads to add the 9. We understand from before, now we have a number pattern. We have a number pattern and we're going to move it the same way. If I need to isolate the 9, I'm going to make it equals to the 10. But 10 is too much, so I need to minus the 1. So now when you look, remember what 10 looks like. 10 look like this, a 0 and a 1. So when we have 4 and I add the 10, it's a 1 and a 0, 1 and 0. So I'm going to add the 1 here. That's what this is. And then I'm going to take away the 1. I'm going to take away the 1 here. So my final answer is 13. World's okayest mom. That's fantastic. So my final answer is 13. Does that make sense? Again, we can utilize it. So can can I copy someone's notes? Hold on just a minute. Let me finish my thought and we'll go review. We'll go review. Don't worry, we'll review. But that's funny. Let's do one more time. Let me do one more, right? So I have my question, right? I have my number 3. I have 3. I'm going to add 3 to my abacus. When I have 3 to the abacus, that's the tough one once you get it off the ones. So we have our 9. When we add our 9, what is our formula? What is the formula that we need to do? Remember, 0, 1 is a 10, right? 1, 0, 1, 0. So I'm going to add the 10 and I'm going to take away the 1. Now, if you notice, there's a number pattern, right? If I want to add the 9, I'm just doing this. That's it. So my final answer is 12. All right. I'll let you guys marinate on that. And let's do a little review for Nora and MC. Okay, so the first thing we're going to do is we're going to understand how to read the abacus. When we read the abacus, we're going to look at this horizontal bar. This horizontal bar, so it's really just moving the beat. Yes, that's what I'm saying. You are the calculator in your head. I need an abacus so I can fully practice. Yeah, yeah. No, yeah, Nora and MC. So when we add it, right? When we add the counted beads, when we look at the counted beads, we want to look at the horizontal bar. When we look at the horizontal bar, we do 1, 2, 3, 4. After 4, we have 5. My head didn't come with a calculator. I have dyscalculia. Some random weirdo. That's fine. You can use the abacus. I have some people that have dyscalculia and they said that the abacus really helped them. I don't know. I don't know. I'm just saying. There's no judging, but I don't know. You might want to try the abacus. It might help you. I don't know. So we have 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. How do I know this is 10? Because I chose this as my ones place. If you look, there's a ones place right here. So this is the ones, and so I have my 1 and my 0. I have dyscalculated too. This is more tangible for me now. I learned in elementary. Woo! That would be awesome if it helps. I think so. I don't know. I can't because I don't have it. I can't tell you if it does or does not. And I don't have a and dyscalculia kind of happened like recent. So I don't know any of the students that actually have dyscalculia. So I can't explain. I don't know if it would. I just hear that it might. I don't know. I don't have an opinion on it. I don't have any research on behind it either, because then when they talk about dyscalculia, they don't talk about math manipulatives, right? I don't understand. Uh, you know what I mean? So I'm something that I don't know. No, no, no. You're not being. I don't. No, you're not being confrontational. No, no. I don't want to be. I don't want to tell you something that I don't know. You know what I mean? So you can try it. The only thing I could say is you could try it and see if it helps. But I don't know. I do. But see, that's the thing. Like on TikTok, there's a few people that said I have dyscalculia and it really helped. That's all I know. I can't. Yeah, like I don't have firsthand knowledge, and I only like to do things at firsthand knowledge. So when I created my worksheets, it was because I wanted to make it exciting. That's why. I gotcha. Respect and appreciate your. Yeah, 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 yeah. Because yeah. I mean, I've taught kids that were on the spectrum and they were fine. I had a couple of kids that were they had some hormonal like they were angry all the time and hormonal issues. I've had students like that, but I've not had a person that have been diagnosed. I'm not putting like, you know what I mean, like I've never had a person that was diagnosed recently, that they had dyscalculia, and I don't know their experience. So oh yeah. So going back to the question, we are counting on the abacus. We do one, two, three, four. And it might be better because it is tangible. And because you're seeing it on the video, it's harder to see, right? But what I would like, if you wanted to try, I mean, they're inexpensive. They're um like I'm selling them for like $10. TikTok shop. There's another one which is a bigger one, and the only reason why this is bigger is because it's 13 columns, and this is just more numbers. That's all it is. And so the difference between the two is not the colors. Sometimes the colors might be overwhelming, and so you might want to do the single colored one. I've had the single color one for 20 plus years, and it's fine. But then I saw this one, I'm like, oh, that looks pretty. So I'm a simpleton. There's the seven column. What's the significance? The significance is just nothing. I like to use it for the younger kids because it's colorful. And then if they wanted to graduate them, right? Everybody wants to graduate. They can get a bigger abacus, and so that's why I would graduate them to a 13 column one. But really, it's all the same. It just depends on how big the numbers are. I read a mathematician lament that was a whole. I think maybe it's I think maybe it's bad curriculum. I think it is, and I think the focus on school is different. So I'm not sure if you were here for that, but like when we in the abacus world, what we do in the abacus world is we focus on the add-in. So we understand what we try to understand how to get the add-in and not focus on the result. So I noticed when I was talking to my friend, and he does second grade math, he wanted to introduce abacus to his kids, to his students. But you know what the problem was? He couldn't do it because it's a mind shift for him. He had to not think about the eight. He had to think about the two. And so he hasn't introduced abacus to the students yet because he has to retrain his mind when we start talking about abacus. So that's why I broke it up into specific numbers. And I think in school, we rush the kids to really get ahead. But what I try to do in my curriculum, in my abacus, I try to go one step at a time. So it's a little bit involved, but once you understand it, it does make a lot of sense to me. It's logical. So if you notice, I have a plus seven, and then after plus seven we learn plus eight, and then after we learn plus eight. But what we're doing is we're understanding how to use the add-in and not find the result, if that makes sense. And so I think that's the one thing that the world, that the mainstream math is doing incorrectly. We're trying to say, oh, how do we make a 10? No, how do we make an 8? Well, we can do 1 plus 7 or 3 plus 5. And I'm like, well, maybe we should do something different. I think maybe abacus learning is similar to hand counting. It is similar, very similar to hand counting. It is very similar to hand counting, but I don't know how big the numbers can. I don't know how to do hand counting, but I know you can do big numbers on your hands. But again, I don't know hand counting. I only know the soroban, so I can only explain. Like, I don't know how you do multiplication division on hand counting. I know I could do multiplication division on the abacus. And then the other thing is, I don't know how you do decimals on your hands either. That's something different, that's outside of my wheelhouse. Yeah. So I mean, there's a lot of things. There's. I mean, I'm not saying that abacus is the end all. I'm just saying that it's just one of those things that'd be kind of cool. I feel like abacus is the gateway to more complex math, because then, once you get the foundation, once you get the foundation, filled, and there's like, then you can move into higher math that's a little bit more complex, and you don't have to worry about, utilizing your mental power on something simple. But I don't think adding, subtracting, multiplication, division is actually that simple. I think we underrate it. I think we underrate the concept of this. And if you really, I mean, if you really think about it, like calculus and all that stuff, that's actually modern, whereas the abacus is old. I mean, it's by the time when we were bartering stuff. You know what I mean? So I don't know if Serene is still here. So what we could do is we're going to count the abacus. We have one, two, three, four, and we're going to do a little review just so people can see. So this is for anytime the horizontal bar is touching, anytime the beads are touching this horizontal bar, we're counting this. So if you notice, these columns are not being counted. These are being zero, if that makes sense. This is all zero. So this is four. Because this is four, we have five. All the top bead has a value of five. So if I did this and I move all the beads, the five, these are all five. But this is five, 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 five. Where's my little? I had my little marker thingy. There we are. There we are. So my little marker thingy. Yeah. So if I did this, that would be five. That would be all five. Oh, sorry. I'd go do that. So this would be five, comma, 555.55. That's what this is. So if I did that, right? Does that make sense? I don't know if Serene is still here. Um, I don't know if Serene is still here or even Nora is still here. Or and who's the other one? The other one was, there was a Q somewhere. Somewhere was a Q. And then, okay, so that's what it is. And then, oh, you're still here, Nora. Okay, good. So did that make sense? Okay, so what we're gonna do is we're gonna talk about after nine, right? After nine, we know that this is nine. After nine, we have 10. I'm sleepy, sad. I found you. I'm gonna follow so I can learn more later. Oh yeah, not a problem. Some random weirdo. I'm happy that you followed. Thank you. I appreciate your comments. Like, it makes a lot of sense. And I like it because I have a conversation and I really like to philosophize math. So we have our one, and then I'm sorry, this is 10. If this is 10, if you notice, this is 10, right? We have 10, 1 and a 0. And then we have 11, 12, 13, 14, and then 15. After 15, we have 20. Now we can count by tens. We have 25, 35, 45, and then 55. I'm glad you're open to dialogue. That's how I can tell you're a good teacher. Oh, thank you. I appreciate it. I appreciate it. Um, Nora, are you still here? So we have 55. Does that make sense? So if I notice, the reason why I'm here is because I have this dot indicator. This dot indicator can be any one, like a Pokemon. So I could choose this one or I could choose this one, but I chose this one. Now, the reason why I chose this one is because then I can have more numbers, right? Every column is a digit. So we are ones, tens, thousands. I'm sorry, ones, tens, hundred, thousands, 10,000. So when we look, right, we have give me a number. Let's do a number. I don't know. I have numbers. I have numbers all over the place. Okay, we'll do this number. We have that number, this, and then this, and then that. So what number do we think this is? It's four digits. That's your little hint. So this is four digits, ones, tens, hundreds, thousands. What number do we think this is? Please put it in the chat. And what we're doing is we're reading the abacus. After we read the abacus, we're going to spring a little bit forward to adding and subtracting. What number do we think this is? 8,254. Yes, thank you, user zero silver. I'm not going to lie, my brain farted when you moved the beats. So one of the things is to actually understand how to read the beats. So 51 actually looks like this. This is 5 and then this is 1. So when we look, this is my ones and this is my tens. So this is my 10, so this would be 50 and then this would be 1. So when we look, this is 51. Now, when I can count by tens. If I add one more, now I have 61. Notice I have 5 and a 6. 5 plus 1 is equal to 6. So then if I do this, this is 5 plus 2 is 7. But it's not 7, it's 70 because we're sitting in the tens column. Remember, the dot is my ones indicator, and the column next to it is the tens. And it's just the same way how we write. So this looks like 71. When we look, it's 71. So my 800, okay, so we had 8,214 is different than that. What I had was that. And this is the 5. So sometimes we don't see that the 5 is being utilized. So this was 800, 8,000, 5, 6, 7, 8. This is 2, 1, 2, 250, and then 4, 1, 2, 3, 4. Yeah, makes sense. Why they end the event? Why did they i- in, invent the abacus when they just used a calculator on your phone? I'm sorry. The calculator came from the abacus. If you don't know your history, the abacus has been around a lot longer than your phone. And you know what? Back in the day, your phone couldn't do calculating. The only thing that you could do on the phone is just dial. I'm just saying. This has been around for like more than thousands and thousands of years. The abacus came out in 2013. Yeah. Right. Where can I get an abacus? You can get it from my website. The link's in the bio. Silver? 2013. No, child. No. No. Okay. So, are you a school teacher? I don't know how I'm gonna answer that. All right. So we're gonna count again. We have one, two, three, four. Because we have four, you're absolutely right. The abacus has been around when we started bartering and having like markets and stuff. That's how old the abacus is. You should join Congress. Thanks. Like 1997. Okay. So we're gonna count four. We have four. One, two, three, four, and then five. You're so funny, Silver. 1997. Who are you, Prince? No, that was the 1998. Party like it's 1998. That's what it was. That's what I was thinking of. Okay. All right. Oh, I don't even know if you know who Prince is. Okay, I'm not gonna go there. So we're gonna add five because we have five, we have six, we have seven, we have eight, we have nine. After nine, we have 10. We have 10, and then what's gonna happen is we have 11. After 11, how do we know? We have our tens and our ones. We have 12, 13, 14, and then 15. And yeah, okay, good. Okay, good. But that's why we're talking. Neon Panther. So we have 15. After 15, we have 16. And then if you notice, Nora, if you notice, we can do this. This is 26. So we have our tens and our ones. I don't know if that makes sense. And then if I add this five, right? This is the five. This is the top bead. Adding the five is 70. 5, 6, 7 is 70. And then we have six. 5, 6, 7, and then six. So we have 76. Yeah? Okay, good. Okay, good. So then what's going to happen is what we did in the beginning is we started moving the beads. Now, what does that mean? Is like what we need to do is we need to understand how to move the beads. We have two and then two. So two plus two. So the question is two plus two. Is there enough beads? We can be like Bob the Builder. Yes, we can. We can add the two beads. Or if we have four and then we want to add the five, do we have enough beads to add the five? Yes, we can. So we're going to add the five. So my final answer is 9. Excuse me. So what we're trying to do is understand how to move the beads. But again, just as we were talking to, I think, Shat, we were mentioning how you actually do the calculations in your head. What you're doing is you're moving the beads. The abacus is really very manual, but all you're doing is moving the beads, and we're trying to track the numbers. So the good thing about the abacus is that it helps you track the numbers, and it also puts a constraint. So that's when you start talking about critical thinking. What does that mean? Because now the question is if I can add in four, I'm going to add three to this question. So the question is I'm going to add three. If I have three, I have three. My question is three. I'm going to add the three. When I add the three, my next question is four. Is it four? Like, how do I make a four? I don't have enough beads to add the four. So what's going to happen is if I add the four, what can I do? I can't add the four. But you know what? Is we're teaching children how to make a five. So what we're going to do is we're going to make a five. As we make a five, right? we're going to utilize this concept. Thank you, Neon Panther. That's the concept. The concept is we're going to take this 4, we're going to isolate it. When we isolate this number, right, because the 4 and this 4 is the same, we're going to isolate that number. What's going to happen is I'm going to have 4 is equal to 5. That's not balanced. So because this is not balanced, then I'm going to minus the 1. When I minus the 1, I'm going to substitute this information into my 4. What does that mean? Now I have directions. Neon Panther, I don't know if you were here for that. It was a mapacus. We were going to talk at a map because the 5 plus 1 is equal to 4. So I'm going to add the 5 and I'm going to take away the 1, and my final answer is 7. Does that make sense? So what did we just do? What we did is we understood this concept and we leveled it up a little bit because mapacus, yeah, yeah, because the 5 plus 1 is giving me a map. I thought that was funny. Yeah, we were trying to find like different names because I thought it was funny. So now what we did is we're understanding how to utilize this formula. We can do it again with 4 plus 4. 4 plus 4. We don't memorize our doubles. Okay, I will wait. 4 plus 4. We do not memorize our nah. Are these pre-recorded? No. Hold, please. No. Oh, Lander. This is not pre-recorded. Let me know if you have any questions. I am everywhere. Okay, okay. So what's going to happen is what? Oh, Nora, I missed the first question. Okay. So the first question is 3. My question when we do it, I have 3. Because I have 3, I want to add 4. Okay, now because I'm trying to add the 4, there's not enough beads to add the 4. We know how to utilize this concept. 4 plus 1 is equal to 5. So what we're going to do is we're going to do a little bit of algebra, right? We're going to put a little bit of magic into it. That means I'm going to do 4 is equal to 5 minus 1. So that means I'm going to substitute this information into my 4. So exactly what Neon Panther says. I have my 3, but now I got directions and say I want to add the 5 and take away the 1. So my final answer is 7. Does that make sense? So what we're doing is we're not memorizing we're not memorizing doubles. We're not memorizing the strategy of doubles, right? There's a strategy. What is it? Doubles plus 1, doubles minus 1, doubles whatever. We don't need to do that. What we need to do is we need to understand in abacus world, we need to understand our formulas. So now we can actually do more. It becomes more versatile, right? So what happens is my second question, if you look at my second question, I'm going to look at it 4. I add the 4. Now I want to add another 4. Roho. Hey, right? To ensure the shopping experience, use the TikTok Live product to sell product instead of directing them to a third-party platform. Okay. So what's going to happen is, right? What's going to happen is instead of learning how to do instead of memorizing our doubles, what we need to do is we need to understand this concept. This concept is now versatile, right? When the versatility, right? We want to add the 5 and we want to take away the 1. So now what we did is we're using this as directions. We're going to add the 5 and take away the 1. So my final answer is 8. Does that make sense? So we can do it again. We can do it again. We have 2. When we add the 2 on our abacus, now it's kind of nice because the reason why is because the abacus puts a little bit of constraint. Because the abacus puts a little bit of a constraint, we now have limits that we know how to maneuver around, right? So when we want to do 2 and I want to add the 4, there's not enough beads to add the 4. What am I going to do? I'm going to plus the 5 minus the 1. Does an abacus help children do math even if they don't have a physical abacus with them. It is a little tougher if you don't have the physical abacus with you. However, you can make it. It's not difficult. Um, I mean, if it's a huge thing, you can actually make it a little like a craft thing, and I would have them make it. It's very easy to do. All you need to do is find like 5 beads. I only have these blocks for right now. All you have to do is have the 5 beads, right? Have a string to go through them, and then have a frame to go around it. And then what you do is you have another string to go right here, and then you have your abacus. So I would make it. If it's a problem to buy, you don't even need to buy an abacus. I would make an abacus, and they would be happy because they're utilizing something that they made. If that makes sense, user 068. Yeah. Yeah, I know there's a few people on my lives that said, you know what, I'm going to make it. Oh, and then if you are going to make it, I would suggest make it at least 5 digits. The reason why to do 5 digits is so you can have numbers, so you can have hundreds, right? Ones, tens, hundreds, and then you could have your decimals like you could do with money, right? With money, the tens and the ones. Thumb is the five, fingers are the ones. No, five five is the index finger. The thumb is the bottom bead. So the only time I use the bottom bead is my thumb when I move it up. So +1, +2, +3, +4, and then finger down is plus the five, minus the five, or -1, -2, -3, -4. I'm talking about the fingers up. Oh, I see. Oh, I see. I don't know. Yeah, I see. I don't have that. Yeah, user. I would make it. Yeah. My question is, if the child learns how to use the abacus, do you think they always need the to need the abacus with it? No, after a while they get to a point where they can actually imagine the abacus in their brain. But if you're pretty diligent on something, like you can see it in your mind's eye. Like I see some questions in my mind's eye. And do I force it? I don't force it, but I can see it, if that makes sense. And those kids that do like the kids that do like the videos that you see them do this, that's what they're doing. They're doing abacus in their brain. Uh yeah, with them to do math. Yeah. Usually the abacus goes all the way with them, and then if you want them to really strengthen it, then they would do it again, without they would do the questions without the abacus. um I don't force my kids to memorize the abacus. I use it as a tool. And so, um if that makes sense. And so even like in my one kid, he's in 6th grade, and what I and he sometimes he gets a little tripped up on the division. And so what I will do is I will tell him to bring out his abacus so he could see it. But he doesn't need it, but it's always nice to see. I don't Yeah, if that makes sense. But yeah. Okay. So Nora, we did that. Oh, I don't know if anybody. Okay, so we're done with that. Okay. Now, if you notice, we did the +5, and then after we add the 5, we know how to take away. So what's going to happen is you'll notice that the reason why we're going to take away is because we have 8. So if the question is 8 minus 4, when we have 8 minus 4, I want to minus the 4. Again, this is the same concept, right? It's a very familiar number pattern. So what we're going to do is we're going to take the 1 and we're going to move it to the other side. So now if I minus the 4, I'm going to minus the 5 and add the 1. So what's going to happen is now I'm going to substitute this information to this -4. So the question is, how do I take away the 4? All I have to do is minus the 5 and plus the 1. So my final answer is 4. And because we know how to add, we will know how to subtract. It goes opposites, right? There's no one strategy is addition and another strategy is subtraction. They go hand in hand. Just like how we add, we subtract. If we add the bead, we subtract the bead. We add the bead, subtract the bead. We add if we have the 4, we add the 4. Notice I'm moving one bead on top and one bead on the bottom. If I'm subtracting, I'm doing this opposite. So now this is a number pattern to add the 4. And that is a little bit learning on how to make a 5. After we learn how to make a 5, we have another concept that we teach the children, how to make a 10. Because we have this concept how to make a 10, what do? Well, when do we use it? We use it when we need it higher than 5. So one of the questions we have was, let's do this one. We had 9. So when we did the 9, we had the same thing. We had 9. Notice it's the same similar way. Because it's a similar way, I have my 9, I'm going to isolate it. What's going to happen? Why? When I have 4, I'm going to add the 4. What am I going to do? I'm going to put the 1 to the other side. So I'm going to add the 9. When I add the 9, it's going to look like this. Plus the 10 minus the 1. Why? Because I have 4 and I have a plus 9. That's my question, plus 9. But I don't have any more beads to add the 9. So now we're going back to the question, right? The question is how do I do it? So I plus the 10 and I take away the 1. So my final answer is 13. We can do again. We can do 2. Let's do 2. If we do 2, we have 2. When we need to add the 9, there's not enough beads to add the 9. There's only 2 beads and I have 5, 6, 7. I only have 7, right? So if I want to add the 9, what do? We know we have this concept. We want to plus the 9. If we want to add the 9, we just have to substitute this in. Plus the 10 minus the 1. So I'm going to plus the 10 and take away the 1. So my final answer is 11. Thank you for the follow, Sabrina. My final answer is 11. Does that make sense? Anybody have any questions? Hi, Vanu. Let me know if you have any questions. And Nathan. Okay. Yeah? Are we okay? Sabrina, do you know how to read the abacus? Should we review how to read the abacus? Are we okay? How are we doing? Hello, Panda. Can you show it the other way around? Can you show it the other way around? Like subtraction? Starting with a 9. Yeah, we could do it with a 9. Oh, oops. Yeah. So let's start with a 9. That's the one over here. Oh, there it is, 9. So we have 9, same thing. We have 9. We don't have enough beads to add the 9, right? And then adding a 2. Okay. Before we add a 2, can we add a 2? We can't add a 2. What is the partner of 2? What's the partner of 2? How do you make a 10 with a 2? How do you make a 10 with a 2? 2 plus 8 is equal to 10. Okay. So we're doing a 2. Right? 2 plus 8 is equal to 10. Why? Because there's not enough beads to add the 2. So when we look, we have to do the same thing. We take the 8 and we move it to the other side. So 2 is equal to plus the 10 minus the 8. So we have our 10. 1, 0, 1, 0, 1, 0. We're going to have your 10. And then take away 8. Take away 8. Take away 5, 6, 7, 8. So my final answer is 11. But see, that's the difference. Mainstream math says that 11 is what we're doing. Do you see the difference? So here's another one. Yeah. So it's all about the add-in. We started off with 2 plus 9. The add-in is the 9 that we were worried about, right? When we switch it, it was 9 plus 2. Now we have to use a different formula. Why? Because our add-in is different. Does that make sense, user? So you have to be careful not to rely on the result. What we want to do is rely on the add-in. It's always about the add-in. The question is always relies on the add-in. What can I do or how do I add? Yes. Yeah. See, that's what I'm saying. My friend had a problem with changing the way he thinks because he's always focused on the result. Oh, isn't 2 plus 9 the same thing as 9 plus 2? No, it's not. Why? Because the add-in is different. The add-in is what makes the difference, right? Great. Yes, thank you for your question. That I'm glad that you asked because that's the one thing to understand, right? To understand the different add-ins, and it's interesting how adults or not kids, right? Because kids just take it in, whereas adults like we have to unlearn some things, and it took me a while to learn abacus. I'm not saying it was, hey Ethan, I'm not saying it was easy for me. I'm not saying it was easy for me because I had to unlearn a few things, which was don't focus on the result, focus on the add-in, right? That's a big thing. I'm lucky I don't have to uh, teach a class, but it took a while, and it's the same thing with like not memorizing doubles because we were always teaching the kids, oh, 2 plus 2 is 4. You know this. No, no, no. In abacus, you can see it. Can I add the two? Yes. Can I add another two? Yes. Right? So those are the questions. I wish my teachers were like you. I'm actually kind of interested and intrigued in math right now. Oh, good. You're voluntarily understanding math. That's funny. Yeah. Yeah, it's the funniest thing. And it's interesting because I think we push the kids to do mental math, I think, too quickly. And I think we just need to stay with something more tangible, whether it be beads or whatever. See, the reason why I think this is a problem, it's because management's hard, right? When you get a lot of these, it's hard to see, but it's easy to see on the abacus. Why? Because if I did 100, this is 100, 001, right? 110. I would have to get a bunch of these dots, a bunch of these bricks, and then I'd have a plate, and then it'd be like, so. But that's the difference between what we're doing here and how the abacus. So, and I keep reminding, like when I talk, I'm trying to be specific when I talk. It's like we worry about we focus on the add-in, not the result. So that's about adding and subtracting the 10, right? That's about adding and subtracting. What we did is we took the concept we're teaching the kids in mainstream math, but in abacus world, we take it one step further, and that's what this is, right? We take it one step further and we do 2 is equal to 10 minus the 8. So we leveled up our we leveled it up. So our 10 is not a freeloading 10. My numbers are not freeloaders. They all work, just like I make my kids work. I'm not. I don't. There is no child labor in my room. You know what I mean? So the idea here is to understand. I mean, some people say it's complicated, but if it's complicated, then why are we teaching kids to do this? You know what I mean? Like, how is this easier than anything? I don't know. I don't know. What I'm just reliving some comments that I get. Okay. So, anybody have any questions? Let me know if you have any questions. If you're new here and you need a review what an abacus is, this is what an abacus is. Thank you so much for the hearts. Let me know let me know if you're new here. Type in 1 in the chat if you're new, and if you are, then we can review. Oh, hey, okay, Ty. So what we're gonna do is we're gonna review how to read the abacus. Oh, thank you, Kyle. So how to read the abacus is 1, 2, 3, 4. Let me know if you have any questions. If you don't have any questions, I'm going to move forward. I won't know if you don't know, right? So you have to stop me if you don't understand. These beads touching the horizontal bar is counted. This is what's counted. This is 4. 1, 2, 3, 4. None of these columns are counted. Because they're not counted, these are all zeros. However, if I did this, then this is now 40. Why is that 40? This is 40 because every column is a place value. So we are ones or tens or hundreds or thousands or 10,000. So when I looked at it, I have one, that's not one. This is 10, 20, 30, 40, which is very similar to this, but it's a different place value, right? It's a different location in the place value. So we have 10, 20, 30, 40. We have 100, 200, 300, 400. Now, if you notice, all the top bead is a value of 5. So this is all 5. This would be 5, 5, 5, 5, 5, 5, 5. And then if you notice, I have this dot indicator. This dot indicator tells me that this is my ones place. You could choose here, but I chose this, like my Pokemon. So I chose Pikachu to be here. Pikachu will be there. 1, 5, 6. So now I have 6 on my abacus. If I do that, this is 0. And I do this, this is 7. 5, 6, 7. All the top bead is a value of 5. The bottom bead has a value of 1. There's 2 and 5. So now we have 7. We have 3 and 5. Now we have 8. We have 4 and 5. Now we have 9. Does that make sense, Ty and Kyle? After 9, we have 10, and it works exactly the same. 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Great. So what we did is we learned how to read the abacus. After we learn how to read the abacus, then we can move the beats. So what we're doing is when I have this is 0. If I have this number, what number is this? Please put in the chat what number you think this is. Thank you for the follow. Whew. Right. So what number do we think this is? Neon Panther says 354. Yes. 300, 1, 2, 3, 50, because it's the top bead. Yes, Alyssa, thank you. Almost, Kyle. You need the one on top. And then there's 4 over here. 1, 2, 3, 4. So we have 354. Thank you, Alyssa. Yeah. And that's the one thing is a lot of people do miss the top bead. But it's always about the positioning of the beads. Because the top bead comes down, that means it's being counted. Yep. All right. So, Alyssa, do you have any questions? Okay. When we look at it, we can start talking about how to move the beads. So when we move the beads, it's like 1, 2 plus 2, but we don't memorize our doubles, right? So what we're doing is we're understanding that we need to move the beads, and now our answer is 4. How did I get that? So my question is 2 plus 2, it gets 4. And notice that we have to ask, can we do it? If we can, then we're going to move forward. Okay. So we have that. That is how you read the abacus. We can go forward into, are we ready for some, what are we doing? Whew, I've been here for a little bit. Okay. Anybody have any more questions? We can do, I guess, silver left. I understand reading. I just don't understand how to add and subtract. Okay. So let's go back. Whoa. So the first thing we're going to do, okay, after we understand how to read, thank you, Alyssa, for letting me know. So what we're going to do is we're going to focus in how to move the beads. And a lot of this is to see whether or not we have enough beads. So my question is also understanding what the add-in is. So this is the add-in, and we want to do a plus 6. So here is 1, and I want to add the 6. When I add the 6, I want to add the 5 and the 1 together at the same time. Now we have 7. So notice I look at the add-in. The add-in is about the 6. So here is 2. I have 2 on my abacus. I want to add the 6. When I add 6, I'm going to do this bead and that bead. I'm going to add it together. When I want to separate it, when I want to take it, when I want to minus, all I got to do is move it away from the horizontal bar. That's what that means. So, no, I'm good. I'm going to bed. But thanks for the knowledge for your. Yeah, not a problem. I just realized you're up late. Yeah. And I'm still going pretty good right now. I came on a little bit late. I went to a track meet and it was so cold. And then I was like, let me see who's on. So yeah, thank you. So Alyssa, did that make sense to how to move the beads? And so a lot of the question is like, is there enough? Yes, there is. So when I add the 5, is there enough beads to add the 5? Yes, I do. So that's what I did. Okay, so that's a little bit about adding. Oh. Here is when we get to the formulas. Now, why are we getting to the formulas? Because we're teaching the children. When do we need to use it? We need to use it when we don't have enough beads. For example, if I have 3 and I want to add the 4, I don't have enough beads to add the 4. So this is where we have to utilize the 5. Okay, good. Yeah, so we have concepts that we teach the children, and it's interesting because abacus takes it to the next level. So these are the two concepts. These are the two formulas. These are the two math facts sets that we have to memorize in order to understand. So when we add the 4, there's not enough beats to add the 4. I know how to plus the 5 and take away the 1. So what I did is I substituted this information into the 4. And so my final answer is 7. And then the next question was like, why did we do 9 and then plus the 2? Notice to add the 2, there's not enough beats to add the 2. But I know, can I do the 5? No, I can't do the 5. Why? Because I'm already adding the 5. So I have to go to the next one over, which is this one. Adding the 2 is plus the 8 minus, plus 2 is plus the 10 minus the 8. So what I'm going to do, I'm going to plus the 10 and then take away the 8. And my final answer is 11. Yeah. So these are about changing out the formulas. And that's what we did. We were changing out the formulas, right? So we can get directions on how to utilize the abacus better. So, anybody have any questions? I was reading this one book. It was really crazy. This is the Chinese abacus, and he was talking about how you can actually do multiplication on the abacus. And I'm like, what? So if you do 6 times 1 is 6. So then if you do 6 times 2, that's 12. What, 5, 6, right? I'm sorry, 5, 10, that's 10, and then 11, 12. So then you trade it in. This is 2, this is 10, so I go here. And then if I want to add another 6, all I got to do is that. And I'm like, that's so crazy. And then I add another 6. So what number is that? 10. So I'm going to trade that in 10. So now we're at 24. That's so crazy. Yeah, I wonder if you could do that for sevens. So we have, and then we do another 6. So now we have 30. Wow. Okay. So what if we did sevens? 7 and then 7. Oh my God, you could do it with sevens. And then 7. We can't do 7 here. How do you add 7 here? You cannot add 7. How do you add 7? Plus the 10 minus the 3. Okay, now that kind of, okay, never mind. Okay, so that is about adding and subtracting. This is also available on the TikTok shop or the other place. Thank you again. My name is Lynette. I'm here to teach you abacus. Welcome to the real world. And yeah, I'm on my 9th book. So Ethan. I don't know if you're still around, but this has finally came in. So I don't know if I showed this to you. So my book actually finally came in, and it's kind of cool. Yeah, maybe I'm multiplying is too advanced for me. No, it's not. It's actually quite easy. It's easy. Okay, you know what? We'll do it. Let's do some multiplication. I will show you how easy it is. Okay, the first thing we're going to do is we need to know times table, right? We need to know our 9 times 9 is, we just need to know that. We just need to know this up to there. That's it. So what's going to happen is if we do 23 times that by 7, let's do that. So the first thing we're going to do is understand, where are we going to start? We're going to start 1, 2, 3. We're going to count our digits. The reason why we're going to count our digits is so we know where we're going to put it. When we know where we're going to put it, this is 3. 1, 2, 3. 1, 2, 3. So I counted from my ones and I counted tens, and I'm going to be at my hundreds. Does that make sense? Because I'm at my hundreds, this is where I'm going to be. The first thing we're going to do is we're going to do 7 times 2. Now, if you notice, we do 7 times 2. We don't say 7 times 20. That's new math. This is abacus math. So in abacus math, we know what this is. That's 14. So I had my 1, I had my 4. Easy? What's next? After that is this. 7 times 3 is 21. Okay. Is it complicated? It's not that complicated. We want to add 20, want to add 1. Add 20. Do you remember how to add 2? We have to utilize the 5. So we're going to do plus the 2 is equal to plus the 5 minus 3. So I'm going to plus the 5, take away the 3, and then I add the 1. My final answer is 161. 161. That's my answer. Easy? Let's see if I can find another one. Excuse me. Yeah? Does that make sense? We can do another one. We could do 30, 34. Yeah, we'll do 35 times that by 4. Wait, why do you start in the middle? Oh, hey, Daniel. Thank you for letting me know. The reason why I start in the middle is because I have my indicator. This is my dot indicator. So my dot indicator is my ones place. That's why. So when I look at it, every place value, every column is a place value. So I have my ones, my tens, my hundreds, my thousands, my 10,000. Yeah. So when we look, we can do 1, 2, 3, 4, and then we have 5, and then 6, 7, 8, 9. After 9, we have 10. How do I know? Because it's my tens and that's my ones. 10 looks like 1 and a 0. That's it. So Alyssa, we're here. We're going to count our digits. The first thing we need to do is we need to understand where are we going to put our number. 1, 2, 3. 1, 1, 2, 3. Third digit. Yes. Thank you, Neon Panther. Third digit. So the first thing we're going to do, what is the question we're going to utilize? Thank you so much, Daniel. So 1, 2, 3. Wait, I'm sorry. And the second one's on the dot. Yes, exactly. Is the decimal points, Daniel. Yes, exactly. These are the decimal points. So when we look, we have our tenths, right? We have our tenths and our hundredths. When we look, the decimal point it sits between the ones and the tenths. No, thank you. I appreciate your comment. That makes sense. So thank you, Neon Panther. We're going to do 4 times 3. 4 times 3 is equal to 12. We're going to add 1. We're going to add 2. Notice we don't do 4 times 30. That's new math. Oh, sorry. That's new math. We don't do new math here. We do old math. We do abacus math. This is what it is. Abacus math does the simple, manageable chunks. Why? Because in abacus, it keeps track of our numbers. We don't need to worry that this is 120. We just need to focus on the numbers and the columns that we're using. So we do 4 times 5. 4 times 5 is equal to 20. It's a 2 and a 0. Thank you, Neon Panther. Thank you. 20. 2 and a 0. And my final answer is 140. Alyssa, did that make sense? Oh, I don't know if Alyssa still here. Okay, good. I'm ready. Okay, I'm ready. Test me, teacher. All right, all right, all right. Let's see. Let's see. Um, hold on, hold on, hold on. All right, let's do this. Here is my maze. Here is my maze. We'll do this one. We're going to start over here. Here is the number. What number do you think this is? If I have that, yep, yes, it is 14. So what this is just understanding how to read the abacus. So when we look, because the 10th and the 1, yes. Thank you, Alyssa. Thank you, Neon Panther. Because the 10th and the 1, yep. This is tens and 1. Yep, this is a 2-digit maze. So it's a 2, so I go all the way up to 2, and then I'm over here. You cannot see that. There we go. There we go. Now I gotta just clean up a little bit. Oh, wait, go back. Oh, go back? Do you hear? I wasn't paying attention. That's okay. We have plenty of places for us to go. So that was a 2 over here. So we're here. This is a, right, 7, and then 9. Okay, you see it. Yep, 78. That's what it is. Yep, 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 yep. All right. Go this way, and now we're over here. And that's what it looks like. Oh, I can't see that. There we go. There we go. There we go. Nice. Yes, thank you guys. So that's this one. And now we're here. So when I look, I have that, I have that. That's what it looks like. Neon Panther. Lissa, yep, yep. Ma'am, you deserve all the gifts. Ah, thank you so much. I appreciate that. That's a 10. Okay. And then we have that. We have this and that. What number do you think that is? Neon Panther. So funny. Thank you so much, Daniel. I do appreciate that. Yep, 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 yep. So we have 33, right? Easy, right? Alyssa, now it makes sense, doesn't it? See, I told you, easy to use, simple to use and easy to understand. 96, 90, 5, 6, 7, 8, 9, 5, 6. Yes. Bruh, just joined. Bruh. Uh, let's see. There we go. What do you have? That. And then that. Thank you, Neon Panther. Alyssa, you okay? Thank you, Daniel. You know, if there's 49 people, 3 people are only talking. 82. There we go. There we go. What's this number? I think that's the funniest thing. There's like, 3 people talking. You're so fast. You're so fast. Okay, we gotta pay attention more. It's okay. We paid. Yeah, yeah. You're making the most out of the class. 76. Yes, perfect. Perfect, perfect, perfect. Okay, 76 goes this way, and then we're over here. Yeah, because I'm trying to make it interactive too, right? Like I know what these numbers are because I did the maze. But the idea is to get you guys to understand. Yes, it is 8. Why? Because this is a 0, and then this is an 8. Yep, 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 yep. 76. Oh, good, Alyssa, you're still here. This is my favorite. That's okay. 8. We're over here. We have that. And that. Oops. Yes. Yes. Yes, it is. Yes, it is. Okay, and our final answer is this one, which is the answer to the universe. You guys. 42. Yes. Yes, 42. The answer to the universe. 42. Anybody read The Hitchhiker's Guide to the Galaxy? That's what that is. So, woot woot. Yep. So that is how to read the abacus. And we did a little bit about adding and subtracting. And that's about it. That's it. Who would have thought I would know this? Wow. Who would have thought that people enjoy reading the abacus? Did we pass? Yes, yes, we did. And I have a whole book. I just got this book. I made it too. Oh, and that was the other thing, the reverse one. What does it mean to be reverse? Let's see if I can find it. Okay. So this is more, so the book I think has like 14 mazes. But this one is a reverse one. Wait, what? Can you do division on that thing? Yes, you can. I wish I taught this sooner. Yeah. Um, so this is the reverse one. What does that mean? Well, when we look at it, there's a box here, and then it gives you a path. But because we give you a path, you don't know what this number is. So here's the number 3. So all I have to do is just color in the 3 dots, 1, 2, 3, and then you just follow the path. And then you look at this one and be, oh, this is 36. How do I make 36 on the abacus? So I go make 36, 1, 2, 3, and then I do 6, 1, 2. Does that make sense? And so then, no, no, no. Let's learn the basics. You guys, wait. Yes, you could do division. We could do adding, subtracting, multiplication, and division. This is what I call a reverse maze because we give you the path, but then you have to find your pillars. So this is 36 over here, takes me here. And then after this, I need 20. So I need to put down 20. 1, 2, and then 0. And then it comes down here. And then this is 23. So I have to put down 23. 20, and then 3. 1, 2, 3. And then it takes me to here. I just need to go find 1, and then it takes me here, and then this is 70, 7, 5, 6, 7, and then that's a 0. Yep. 2 by 4 digits. We could do that. But I do notice it's like there's not a lot of videos that are out there for that. That's what I noticed. So that's what this is. And this is available where? Over here. Which I cannot say. But that's me. My name is Lynette. I've been teaching abacus for 20 plus years. And you can find my books either at the TikTok shop or here. Mm, So the basics. You should put the link in your bio. I have the link in my bio takes you to getting this abacus reference. So you can get this if you want, how it just shows you how to read the abacus and then tells you how to do 1, 2, 3, 4, and then it goes to 5, 6, 7, 8, 9, and then 10. So this is what's in my bio. You can get this for free. 5, 6, 7, 8, 9. And then 10, 11, 12. And then if you want, I also have a link in a bio. YouTube. Anyways. I can help with that. Okay. So that's what this is. All right. Okay. What are we doing? Are we doing multiplication? We did multiplication. Alyssa, did that make sense? Multiplication? Okay. Thank you, Daniel, for your help. I do appreciate it. But you can use a link tree for more links. I could. I could. I had one set up. It's okay. I'm thinking about it again. I'm not organized enough to figure it all out. But I could. I just have a lot of stuff. And I just gotta figure out, what to filter in and what to filter out. All right. So other than that, it is getting late. We need to maximize. Understandable. Yeah. I did have a link tree, like a link in bio kind of a thing. But then I'm trying to figure I think what it is I'm still trying to figure out who would be interested in all my stuff. And that's what I'm still trying to figure out because I've been teaching in a vacuum. And so whoever came to my school was who I taught, but then, or my learning center, but then I don't talk to any of the parents. Whereas for you guys, it's different because Sophie's here. Is Sophie, are you still here? Oh, sorry. Yeah. Oh, sorry. There we are. Yeah, multiplication is easier than I thought. Yes. You know why? Because we put it on the abacus. Because we put it on the abacus, we don't need to worry about our place values because all of the stuff happens to here. If that makes sense. We could do another one. Let's do a couple more. We could do this one. Let's do another color. Let's do this one. This will be easy. Times that by 4. Again, we're counting our digits, right? We count our digits. 1, 2, 3. When we look, we do 1, 2, 3. How do I know? Because we have 3 digits. So I'm going to put my finger here. Yeah, we're going to do the first one. 4 times 5 is equal to 20. I have my 2, I have a 0. Don't forget to have the 0. When you have the 0, you're going to move your thumb or move your finger to this column. You have to remember there's a 0. So when we do 4 times 3, 3 times 4 is equal to 12. Plus 1, plus 2. So my final answer is what? 212. That's my answer. Yeah. Okay. Thank you so much, Daniel, for the galaxy. I'm on my laptop. You, oh, really? And they hey! Oh, hey! That's fantastic, sign. I'm so excited. I'm so excited. I was actually working on my last one. I'm working on my ninth book. And I'm doing the -5. You know what? You know what? Let me give you a little preview. Here is a preview. Do you want to see a preview of my next book? This is going to fall in line, if that's okay. I can show you a preview of my next book. It's almost done. I'm actually quite excited. um, I'm still waiting on the algorithm thingy that you showed me the other night. Oh, you know what? Um, oh, you know what? Okay, hold on. Hold on. It's over here. And okay. So, you know what? Let's go on a field trip. It's over here. I did it. Where are we? General? Is it general? Yeah, there we go. So, if you look, in my Abacus store, we go over here. So in here, it's in here. The algorithm thingy, it's in here. So it actually includes a little template to isolate as well, if that makes sense. So it's right here. It's called Abacus Framework, and inside there, what's inside it? It's oh, hold on. Let me see if I can find my pages. So I have the framework thingy which you saw, and then um oh, and then it includes this, which is a commutative property where it just lists out the adding of the making of the 5 and then the subtracting of the 5. Yeah, this is a digital download. I was going to try to sell the laminated, but I'm sure you can laminate yourself. But that's what I was going to do is I was going to have two different versions. One you can order and then you get it laminated, or but this one was kind of cool. This one was really cool. It was a little paper thingy. You know how to do the paper thingy, right? Yeah. So with the paper thingy, right? I know I showed you where, yeah, there's the thing where you can open it up. So that took a little bit of time to figure out like the dimensions, but I was trying to get it to a point where it was easy to use. So you just fold. So you cut around it, and I also provide video instructions how to make it. All it is you cut around it and then you fold here and here. But yeah. But that again, it is a digital download. I was just trying to keep up with all the stuff. It's just kind of crazy. So yeah, that's available. And so there's that one, and then there's the worksheet one. Oh yeah. So sign, did it help with? Did you talk to your daughter about like how the beads work? Did that make sense when? Because I know you made an epiphany. So was it? Were you able to translate what you understood? Yeah, the paper thing is very helpful to focus on each row. Yeah, okay, good. And yeah, it is available in that framework. I thought that was a good one. Um, because I know my kid, he had a problem with too many. It was the abacus was too much for his eyes, and he gets very he gets very confused. So what I started doing is I had this little paper thingy to help him focus on just the specific column. So there's that. Oh, so then here is the preview of the next book, which is this one. Oops, was it that one? Yeah. And this one is talking about the -5. And again, we're talking about just how do you make a 5. And it goes into review, like how to do a 5. And then we talk about flowers in a pot. Yeah, we started to do the X and the -X. She's like, oh, yeah, that's interesting. So I'll continue using your books. Oh, thank you. I do appreciate it. So this one here, and I try to make it like more, I try to make it try to make it more interactive. But your teacher does your teacher is your teacher okay with it? Because I know you have an abacus teacher, right? And so this is just again solidifying how to make a 5. But then we had to switch it a little bit and how to make a -5. So with the -5, and then I take it one step. I take it one step at a time. Where if we want to make a 5, what's the missing number, and then this is the answers. You're seeing the answers. Um, but then here I show you how to do it, and then I try to show what it looks like oh, I guess I need to put that. So then again, this is again just the activity. Circle the numbers that you are going to use, and so forth. And so then there's a spin the wheel, and then there's a tic-tac-toe. She's 3. She hasn't started school per se. I'm teaching her because she's so. Oh, I thought you had an abacus teacher. Um, Oh yeah, I assumed that you had an abacus teacher, but that's really good. That's crazy. That's fascinating that she's so young that she's learning. And then I haven't finished it yet, but I got to do color by number. And then it goes to making a 2. Is this making a 2? This one's 2. No, this one's 3. How to make a 3. And again, there's the spin the wheel, and then tic tac toe, and again, this is the color by number, and we just go through it. And then after that, after you figure out all of the numbers, we go to 1. And then after that, there's all these activities. Where this one was kind of cool. I like this book already. It definitely order when it's available. Oh yeah, this one was kind of cool. So this one is you had to figure out what the result is, right? So you figure this out, you cut it out, and then after you cut it out, you have these numbers, and you got to match it. And then this one was hidden numbers, and then this one was I try to do what do you call it? Word problems, and I still have my mazes. So this is the answers. Oh, thank you, Alyssa. Yeah, you're welcome. I need to get some sleep now. Good night. Yeah, good night. Good night. Have a good night. Thank you again. I will see you in my next live. And then that's it. Those are the different variations. And this is the hidden word, and then this is the word problem, and the maze. And then I just kind of do it again. And then I think I'm going to do. I don't know how many pages it is, but that's the idea. Yeah, yeah. So I'm quite excited. And then after this, I have to work on the -10 because I have a student that's coming in. He's already finishing up how to add 10, so I have to do minus the 10. Yeah, so that's where I'm at. I've been, yeah, trying to get it out. Ooh, nope. There we go. Oops. Yeah, I've been trying to. I need to get my books out the door. But yes, thank you. I appreciate it. So, Other than that, hey Merv, welcome. But it's been for a little bit. Ah, Daniel. Daniel, are you still around? I don't know if Daniel's still around. So that's a little bit about me. And I'm trying to keep my abacus. I'm trying to keep my store up to date, but it is a little bit. It does take a little bit of time. Wow, there's still 46 people in the room. What? Lena. That's funny. Lena. All right. Thank you for the hearts. Ethan, are you still around? You should be in school by now, shouldn't you? Okay. Neon Panther, you still here? Oh my god, I can't believe it's one. Okay. There's 51. There's 51 people in the room. All right. No, I am. As I am. You need to go to bed. You need to go to bed. Oh my god, it's like 4 in the morning for you. Oh my god. You guys are nuts. Yeah. That's all you're gonna say? Yeah. It'd be crazy if I saw Audrey. I'm like, oh my god, Audrey, go to sleep. Dark myth. That's funny. All right. It's late for me and I gotta get to bed. I gotta get to bed. I gotta get up. I gotta get up. Yep. So I saw her stream. Yeah, right? Yeah. Oh, yeah, cool. Yeah, she does algebra and like all the other stuff for things. Excuse me. Um, I got. That's how I got some of her like verbiage because she talked about like isolating the variable and two-step equations and all this and that. I was like, oh my god, that's what abacus does. So a lot of like what a lot of what abacus does, it feeds into algebra, which is very interesting. But anyways, all right. Oh my. Okay. Anybody have any questions? If not, I am gonna sign off. I am gonna sign off. Whew. Anybody else have any questions? All right. All right. Thank you guys for joining me in my live, and I can see that feeds into algebra, which is totally cool. Yeah. Yeah. Division. Oh, I can't do division right now. I'm spent. Uh, yeah, I'm sorry. Excuse me. I am a little spent now. Yeah. It's okay. Okay. Thank you. Yeah, it's interesting. I was just thinking like it's just interesting how abacus does feed into algebra. But I didn't know this obviously. And then people who teach abacus doesn't talk about it either. And it's really quite interesting. And how so a lot of the verbiage that I use is mainstream and it's not very it's not used in the abacus world. Yeah. Okay. Okay, Neon Panther. Have a good night. Have a good night. Oh my goodness, there's like 49 people still here. I have to end it because I'm tired. Oh, yeah. Okay. So, signed, if you have any other questions, let me know. Um, I am available on YouTube. I'm going to have office hour, office hour. If you have any other questions specific, I have one like my student parent of a student comes in and she asks a lot of questions about like the specifics of like how to add and subtract, and it's different than the TikToks. And so this one is very specific. She has very specific questions like how to add a five, how to make a five, or how to add a 10, and then two-step equations. I don't know. Yeah, so I'm available for her, but you're welcome to join. I usually open it up to my email list, and I only go live on YouTube. For this one specifically, I call it office hour. I go once a week, and I go 9 o'clock Pacific Standard Time on Thursdays. But yeah, okay. Okay, thank you. All right, I'm gonna sign off. Thank you for the heart. Oh, Dan, I don't know if Daniel's still around. Yeah, have a good night. Thank you, Daniel, for the galaxy. Okay, have a good night. Thank you so much for the hearts. And if anybody wants some of the books, they are available on over here. They're available here. My name is Lynette. Thank you so much. Have a good night, everybody. If you want the reference sheet, it is available on my website. It is also in my link in my bio. I want to follow me on YouTube. I'm there too, and I also have worksheets on Teachers Pay Teachers. Yeah, I'm trying to be more proactive on the resources that I have because I have a lot of resources, but I just forget about all of them. But yeah, thank you again, everybody. Thank you so much for joining me, and I will see you guys all in my next live. Have a good night. Oh my gosh. That's so crazy. 1,000 total views. He has 1,300 followers. Jesus. Rich gem. Buddy. Oh, Daniel. Follow back. He looks young. Oh, I gotta stop.